We intuitively recognize that safety must be an important consideration when factories operate. Conveyors, cutting tools, welders, robots, packaging, labeling, and more present hazards to operators and other nearby workers. What if I told you that most machine accidents do not occur during normal operation, and that the indirect costs associated with these accidents might be bigger than the direct costs? If that grabs your attention, stick around to learn more about these important safety issues and how to address them with improved technology and data. Welcome to Tech Chat, sponsored by Mouser Electronics, where we chat with engineering experts about the latest technical innovations that are shaping and reshaping our world. Our special guest today is Chanakya Gupta, a senior offer manager at Schneider Electric. Welcome to Tech Chat, Chanakya.
Dale, thank you for having me.
Yeah, we're glad to have you today, and we're looking forward to this talk. So what are you going to be talking to us about today?
Dale, I'm covering the Harmony XPS Safety modules. This is a revitalization, re-energization of our old preventative XPS Safety modules. And we're really excited to bring this innovative safety-related technology to the market.
Well, I'm looking forward to it. I know there's been a lot of advances in the safety portion of our industries lately, and so I'm looking forward to hear it. So let's jump right in.
Great. So just about as an introduction to the agenda that we're covering today, I'll be going over the introduction to machine safety. Why do we even need to consider it? Something that's really important to me as an engineer to always consider. I think your listeners would appreciate it too. I'll talk about the risk assessment and risk reduction, that you have a methodology to do that for machines.
That sounds like a great outline. So why don't you take us right into it?
We'll go into understanding safety relay applications and then introduce the Harmony XPS range, along with the technical features and the value proposition to the market.
Yeah, your image there of the iceberg with all the indirect costs being the much bigger portion of it is probably something that people maybe don't spend enough time thinking about when they're investing in safety for their factories, because they're not recognizing the real risk from just a financial perspective of being exposed to these kind of issues.
The machine safety, and why is it important? There's a lot of hazards that exist in our manufacturing environment today. Most of these threats come by the way of what it does to human beings and personnel and operators that are working in and around these machines. There can also be damages that happen to equipment and any auxiliary affiliate products that are by the machine. This results in increased insurance premiums for manufacturers and, of course, loss of production, penalties. And there's lots of, just second level and second degree negative image related repercussions for companies. All in all, human life is the most important value, of course. And to take care of it as, these personnel as human resources. And we want to make sure that the safety processes, equipment are in place to ensure the safety. The machines are also equipped with the correct safety interventions to ensure there's a safe living environment for operators on the shop floor.
Yeah, that is a fascinating statistic. You mentioned here that it's a global concept, but it's also that life cycle, because I think when most of us think about safety around a machine, it is just operation. It's one of those bullets you have here, and it's perhaps not even the most important one. And so that's a great way to start rethinking about machine safety.
Absolutely. And really, it's a good thing you pointed out the hidden nature of some of these repercussions we spoke about. Yeah, there's the considered cost, of course. When you're trying to rapidly ramp up production, it's very easy to miss some of these indirect costs that you just identified and mentioned. So really, machine safety is a global concept. This isn't something that's unique to, say, just the US alone. There are machine builders in Turkey, machine builders in Italy, Germany, who are importing equipment all around the world. The US is an import market. The Americas and Asia, there's lots of packaging equipment that is rapidly moving all around the world, depending on where there's going to be greater production. It's important to ensure that there's machine safety included as part of the equipment, regardless of what geography it's operating in. It's also important for me to highlight we have so many accidents around the machine that occur during installation and small changes that are being made to the machine. As the machine is installed on the shop floor once it arrives from the factory.
Can you give us an example of how that risk assessment is done in practice?
There's some of these, again, often missed areas when we think about how to make a machine safer, not just during its operation, but also in its maintenance. When we think about machine safety, how do we go about assessing the risks that a piece of equipment poses in relation to personnel who will interact with it? There are standards. There's ISO, such as the ISO standard 12100, that's globally accepted and largely adhered to. That lays out the various steps that go into determining risk that a machine poses. The machine builders need to take into account and determine the PL risk level of a machine that then needs to be reduced with further interventions. Inherently, machines, large machines, even smaller machines, but often machines with moving parts pose such risks to operators. It really starts with determining what are the limits of the machine, how much possible harm could this piece of equipment cause. We need to identify the potential hazards, but there are electrical hazards, mechanical hazards, with things flying off the machine in the event of an unsafe shutdown, for example, as well as estimating what the losses would be to the environment around the machine in the event of such a dramatic shutdown. And then doing a risk analysis. Could some things go off? What is the severity of this risk? And really, what is the frequency of the affiliated risk? And once the machine risk is evaluated, of course, machine builders take the steps to put in the physical safeguards. Once they've exhausted this ability to reduce the risk around the machine intrinsically and physically, then we get into the design, the machine design phase. We introduce, other safety interventions through the introduction of technology, such as safety relays and safe shutdown modules to bring the machine to a standard safety operating level.
There's the triangled exclamation at the bottom mentions that after each new measure, the risk assessment must be restarted. And I assume that's any measure of any change to the process or the equipment or any new safety measure that you implement. Is that what that's referring to?
That's a great question, Dale. The slide here actually outlines a decision tree on an exact risk assessment that was done for this sample machine here. So again, started with assessing, analyzing, and then determining exactly what level would be aiming to hit. Again, this is the risk assessment stage. There is another standard that comes with the ISO 13849-1, where different performance levels are outlined. That's what we're trying to identify through the risk assessment. Like I mentioned in the previous slide and in this discussion, what we're trying to do is reduce or minimize the risk that is posed by a machine. Where at this point, we determine the severity of injury, the frequency and exposure that it has, as well as the possibility. So you can see here what I'm demonstrating, if there's a machine can cause serious injury and the exposure is frequent, at another level, the potential is scarcely possible, which means it's still possible. This leads to a machine requiring the highest level of risk reduction. This would be a PLE rating. Some of your process users or the process industry, safety practitioners therein, might be familiar with the SIL rating. The PLE is in essence an analog for the SIL 3, which is the kind of safety reduction that is required in operating conditions such as oil refineries and nuclear plants. I'm just here sharing that to give you an idea of what a PLE is.
And this way of looking at the whole machine solution kind of has to be overlaid with that life cycle you're talking about, because let's say you're doing some maintenance, well, maybe some of the monitoring gets turned off at one part of that. And so I could see how you have to really, it becomes a complex problem overlaying what you're looking at here with the whole life cycle of the operation of the tool.
And within the machinery context, this could be things such as packaging lines and large e-commerce vendors where they're moving fast, gas packing equipment. There's still humans around the machine, but just the pace at which equipment is running, would mean that in the machinery context, you would need a PLE rating to reduce equipment and safety interventions with a PLE rating to reduce that risk.
Yeah, I can vouch that these are not hypothetical things. I still have a scar on the back of my hand from a cut I received working around a metal cutting machine. So after a half dozen stitches, I know that these are not theoretical problems.
Absolutely, Dale. So the idea there is, once you've introduced a safety intervention, just because, the machine itself could have a safeguard introduced, like a mechanical safeguard. You could have increased the distance, even change the room the machine is in to make it more safe. Once that is done, then you'll have to redo the risk assessment to see what the revised risk level is once you've made these interventions, physical interventions. And with this slide here, I'd want to highlight that with Schneider Electric, there's a machine builder out there considering safety intervention, what Schneider has to offer. Really, we have solutions and offers available for the entire machinery lifecycle and operating process, from acquiring the information with sensors like curtains and push buttons to pull cords, and then actually monitoring and processing the safety signals sent by the sensors and safety relays, or programmable safety relays and the safety controllers and safety I/O. Then, of course, there's a need to stop the machine once the signal has been processed, a risk has been identified. To stop the machine, there's drives and safe stops on all our drives and motor systems that we supply industry with. I mean, these are things you're considering, from the design phase all the way through the build and maintain phase. We work with a lot of machine builders, so they have legacy machines that have never been correctly instrumented for safety. And we work with them to add new safety interventions like light curtains, or we may introduce safety relays for machines that previously didn't have any safety relays. Specifically talking about safety relays, it's important what kind of machines we're talking about. Inside the machinery segment, safety relays are typically required in all segments, from packaging to material handling to wood cutting machines, and just food and beverage packaging machines as well. And it's really simple machines and some performance machines where you could see the need for just pure safety relays. The idea is when machines increase in complexity, you're typically designing safety PLCs and controllers that are running those machines, because those tend to be more real-time ways to design safety. I think, the last slide I did talk about the different kinds of machines, but it's also important to just illustrate what a typical machine would look like. So, a cutting tooling machine to what a typical mold extrusion machine looks like. Conveyor lines, we're all familiar with those. We see that, baggage claim sections in airports all around the world. Packaging, labeling machines are the fast-moving machines, as well as bottling in the food and beverage industry, for the different kinds of machines. Now, again, I want to illustrate with this slide typical hazards that exist around the machine. There's cuts and fractures that can happen if there's a large mechanical movement in the machine. Entanglement is something that, is a common hazard in the textile industry or labeling, packaging industries as well. Impact from being too close to a robotic arm, or burns from fast-moving motor shafts inside those machines. Crashing is always a risk, again, around material working types of machines, not exclusively, of course. And that's where you see in material working types of machines lots of more use of chemicals, steam, sprays, electrical arcs, etc. These are just some of the common hazards that exist around the machine that we're trying to account for in our risk assessment. We minimize the risk of the introduction of safety intervention, such as safety relays. Absolutely. These are real life incidents that we try to make sure we eliminate or minimize as engineers. So here, Dale, I just want to use as a jumping off point to introduce the Harmony XPS range. Really, the entire range has two key functions. One would be to safely stop a machine. The other would be to safeguard it. There are different functions on these Harmony XPS relays, depending on which model is chosen and selected, where it can do a combination of stopping a machine safely, as well as introducing switches that have different wiring, magnetic switches, have different wiring, safety light curtains, as well as zero speed monitoring as another safety function that the XPS range is capable of performing and providing to customers. The idea here is to ensure that the torque on the machine or the motor is monitored to ensure there's no motion before an area can be safely accessed by an operator.
Can you explain the difference to me between stop categories 0 and 1? I'm not familiar with those.
Stop case category 0 would in this instance mean an instant stoppage. Stop category 1 is something that has a time delay. So this slide here, Dale, I'm trying to illustrate the different variants inside the Harmony XPS range and what other different functions those specific safety modules are capable of performing. So for example, an XPS BSC is a machine stop category 0. It's capable of assisting with, pull card type applications that can, just provide that. It's also got the guard switch capability. But then when you get into some of the more advanced modules here, you can see they're capable of performing a variety of safety functions, including, being used for an emergency stoppage of a machine. But it's also able to provide support for safety interventions that use RFIDs. And also, then, you can see the extended list, magnetic switches, light curtain capability, as well as safety maps are all supported with these more advanced modules.
That's a helpful figure showing the different options and kind of making that really an icon, make it easy for customers to look at, what problem am I trying to solve, and then easily identifying the right Harmony XPS product for their needs.
Absolutely. So as far as technical features go, the new designs that we're introducing to replace the old Preventa line, these modules, again, will either be 22.5 millimeters wide or 45 millimeters wide. So it's really both either a single or a double wide. These modules are capable of supporting 2 power supply variants, both the 24 volt DC or the 48 to 240 volt DC. The idea really is to make it as convenient as possible for customers to integrate safety into their existing architecture, oftentimes without needing to introduce a dedicated power supply for these new safety modules. These modules are expandable with a side expansion capability, which is really helpful when you're mounting things in DIN rail. And you don't have to use any additional wiring for expansion. These modules are, again, both available as a screw and spring terminal, depending on the preference of customers. Typically, in North America, we've seen screw terminals being more widely requested than the spring type. Now, of course, the spring terminals are becoming a lot more common. As you know, we import machinery from around the world, and if there is an end user specification requiring either.
Now, you mentioned the expansion. So does that make it easy if I design my system and then I decide that I need to add some additional safety features that I can then just expand that quickly and easily to, let's say I'm going to add a light curtain to an already existing system?
So in this instance, expansion would be allowed for greater, greater outputs if a customer is looking for that in their particular safety instance. That's what the sort of expansion is for, is to allow for that scalability. Less so to introduce any new safety functions in themselves. It's truly just an extension of the existing safety intervention we're trying to work with.
Okay, that's a helpful clarification. Thank you.
Next, I want to talk about the unique value proposition that the Harmony XPS range presents to customers. What is the ability to access advanced diagnostics? The Harmony XPS modules are capable of providing different pulse patterns, which I'll get more into. These give operators access to actual relay diagnostic information, which can help further reduce machine downtime in the event that there is a faulty safety module or there's some issue with the wiring of the safety module itself. And then, of course, for preventive maintenance, you can have planning the maintenance appropriately, as opposed to suddenly being introduced to a module failure on your line. So, again, great value from the advanced diagnostics there. The second UVP really comes in the form of preventative maintenance diagnostics. If you know how many want to know how many operations have been run by a particular safety module or safety system, and how many more rated operations are remaining. That can be helpful. Again, really helpful when you have to plan to change out a light curtain, the push buttons, or if there's anything else on the machine that is a mechanical defeat. It might be wearing out. That can cause more failure. And that's the kind of information a customer can also access about the expanded safety chain, if you will. So not just the module itself, but also the safety mat, like it, etc.
That's really fascinating. I mean, those terms, advanced diagnostics and preventative maintenance, have become such an emphasis in the industry the last couple of years for the tools themselves. But I don't know that we tend to think about it around the safety things, because sometimes that's an afterthought. You know, you design and build your system, and now we'll figure out how to add safety to it. And we spend all this time thinking about how we're going to maintain the system. But all those issues are still important for the safety system as well.
So to further emphasize the universal nature of the Harmony XPS range, the selectable functions are really which is dedicated safety relays that allow customers to have a single safety module in this instance that is capable of performing a variety of safety functions, as opposed to having a dedicated safety relay for each safety function. What this has allowed Schneider Electric to do is reduce the number of safety modules that we offered into the market from 64 to 28. So when customers think about inventory and keeping safety modules in hand for future expansion, they can do so with a reduced number of references. Like I mentioned, with the side connectors for the output extension, again, this is something that they can readily do without needing any external wiring. We also provide customers ready-to-use certified safety architectures that we get vetted and tested by TÜV every year. What this does is ensures customers that they can pick up a validated safety architecture and introduce it to their engineers, and their end customers, confident that safety level has been achieved for the entire architecture. So here I just want to also illustrate to you that the advanced diagnostics that I spoke about with the Harmony XPS, what is different in the XPS universal safety relays versus the traditional or legacy preventative safety relays, is that in the past there was just limited diagnostics because you got one message from the safety relay that you read out to your PLC. With the Harmony XPS safety relays, we're able to publish and provide statuses using pulses. It's like a binary code in the pulses, and this combination, there's 40 codes that we're able to express statuses and detect errors. So really all you would need is a digital input or PLC to access these different outputs. And with that, you're able to enunciate a variety of diagnostic codes.
And that has advantages in reducing downtime. I mean, if you get a code that says, this input's got an error, like you say here, and you might know that a particular sensor is having an issue. And so you can enable your maintenance team with the information to bring the right products or send the right person to the associated tool expert out there and solve those problems much quicker and get your tools back up and running. And so that additional data has ultimately a financial benefit as well.
Absolutely. And you can think about trying to just data together. Let's say an M262 Modicon PLC, which has the ability to publish data to cloud services. You really bring up that enhanced value of asset monitoring and preventative maintenance data, like you mentioned. If you know exactly the issue, and the operator doesn't have to travel hundreds of miles unprepared on what it is they're going to be fixing and diagnosing.
And are these blocks available for download on your website?
Earlier, I mentioned the two function blocks that are quite useful for preventative maintenance, from that point of view, to show greater diagnostics inside the programming environment, which can be then shown on an HMI. So this is just an illustration of these function blocks that I was talking about. inside the Machine XPS software environment and what it would look like for customers using is a quite useful preventative and interactive view to show the greater diagnostic inside the programming environment. There's a proof of test total that customers can see, the number of operations for an input device or an output device, and the safety module itself. Because sometimes you step back and you think that about safety is something that should just work when it's supposed to.
Well, I know I've appreciated seeing not only the products and what they can do, but as you've forced us to kind of think about the whole life cycle and the global aspect of safety, I think it's something that will benefit our listeners as well. As we get ready to wrap up, is there any kind of last second takeaways you'd like to pass on to the audience?
In conclusion, I just want to highlight from a modernization standpoint what the Harmony XPS range has done in terms of replacing the Preventa XPS range. The Harmony, the number of references are significantly lower. And each of these references oftentimes is replacing, up to 4 old Preventa modules. And this illustration shows how the different Harmony XPS modules address machine safety functions, starting from stopping the machine and then safeguarding it, to guard switches, big data switches, light curtain, etc.
So we've covered a lot of ground here today, and you provide a lot of helpful information, including that what kind of products fit to what applications. Can people that maybe are looking for more additional information to just reach out to Schneider Electric and get some customer support help if they're looking to design new safety features into their products?
Absolutely, Dale. We have solution architects. We have application design engineers. Schneider tech support is also extremely capable, and there's a plethora of literature available on se.com for each of our products to download. This includes data sheets, technical sheets, instruction sheets that customers can access. I think, Dale, I'd really like to emphasize the importance of machine safety for machine builders. The economic environment we live in with the supply chain challenges that have existed, it's compelled machine builders to expedite how quickly they'll build machines and ship them out to customers to keep operations running. I do believe that while we ensure that there's as little downtime as possible as far as production goes, it's important to do so safely. I'd really encourage customers to always have an eye out for safety on their machines and consider Schneider Electric solutions. They're quite comprehensive, as well as our safety chain solutions with validated architectures that we provide for free on our website.
Yeah, and we're thankful to our friends at Mouser Electronics who sponsored today's Tech Chat. Schneider Electric products are available for purchase over at Mouser, so check out the Schneider Electric's products page at mouser.com. And please join us again next time on Tech Chat, where we chat with the leading technical experts like Chanakya Gupta from industry-leading companies like Schneider Electric, who are changing our world every day.